Yay, calculus. What a joy. Doing page 226, 1 through 10. See how far we get. Number 1, we have sum of two non-negative numbers is 20. Find the numbers if sum of their squares is as large as possible or as small as possible. Alright, so we need our two numbers. We'll choose x and y. The sum of these is 20. We don't like 2. We like 1. So let's solve for the other. So our two numbers are now x and 20 minus x. So we need to maximize and minimize the sum of the squares. So that would be the sum of the squares. So as a function of x, the sum of the squares would be x squared plus 20 minus x squared. And that would be the same as x squared plus 400 minus 40x plus x squared. So that's 2x squared minus 40x plus 400, which will then differentiate and set equal to 0 to maximize and minimize. So differentiating 4x minus 40, I set it equals to 0, so that means that x equals 10, which leaves the other one to be 10 as well. So 1a max is going to be 10 and 10. Now the minimum, all is going to be the same. Set it equals to 0. This is our only place here. Okay, let's do the second derivative test. Because we have 10 and 10, sort of skip to the fact that was a maximum. Maybe it's a minimum. The sum of the squares. Yeah, that would be a minimum. So if double prime of x is going to be 4, so that's positive, which means this is concave up, or a minimum. So let's change that to minimum. Excuse me. I was rushing ahead, assuming that just because I had a flat spot, a maximum or a minimum, that was a maximum. So that's the minimum. The maximum value, if we're doing non-negative numbers, then it's not going to occur in a manner that's cup over, cup down. So we're going from 0 to 20. So that's going to be minimum at 10. And the minimum at 10 is going to be 200. At 0, be 0 and 20 squared will be 400. And at 20, it's up at 400 again. So we can be sure we look like this. So our maximum values occur at 0, 20. Or 20, 0. It's the same difference. Moving on to B. One number plus the square root of the other is as large as possible or as small as possible. One number plus the square root of the other. So we've got a new function. We have one number plus the square root of the other number. And we want this to be as large and small as possible, so we'll differentiate. We get 1 plus, remember this is 1/2 20 minus x. Sorry, 20 minus x to the 1/2. So that makes 1/2 20 minus x to the negative 1/2 and times negative 1 by chain rule because of this negative x here. So let's look at that a little better. This would be 1 minus 1 over 2 square root of 20 minus x. We'll set this equal to 0. That means that 1 equals 1 over the 2 radical 20 minus x. And We can multiply both sides by this. That means that 2 times 20 minus x equals 1. And that means that the square root of x equals 1/2. Square both sides. Squaring both sides, we get 20 minus x equals 1/4. That means that x equals 19 3/4. So 19 3/4. Alright, so this is 1b. I don't know if it's max and min yet. We won't make that mistake again. This is going to be 1/4, 19 3/4, or 0.25 and 19.25. Now, to determine whether or not this is a maximum or minimum, do a second derivative test. Let's see here. So our first derivative, when we had it, was sitting right here. That's 1 minus 1/2, 20 minus x, negative 1/2. And there's our second derivative. Is going to be, come to think of it, the one minus the other probably would have been better served by doing 20 minus x plus radical x, because that would have made this much simpler. But so be it. We need the algebra practice. Wouldn't hurt at all. And we don't always do things right the first time. So that goes to 0. Negative 1/2 times negative 1/2 is 1/4. 20 minus x minus 3/2, then times minus 1. And so where this equaled 1/4 is where we were. I want to see if this is positive or negative at this value. So f double prime of 19 3/4 be 1/4. When x is 19 3/4, 20 minus x is 1/4. And times the negative 1, we'll just stick that negative out front. And so let's evaluate. That's negative 1/4. That's going to be 1 over. Well, if we make this positive, we can just change this to 4. That's going to be 4 to the 3/2. So that's going to be 4 square root cubed. So that's going to be 2, 8, negative 2. It'll wind up negative 2, I believe. But negative 2 is negative, which means that it is concave down. So concave down means that there's a maximum. And therefore, to minimize this, will be again in a similar situation as this one, but this would be up like this. So just check the endpoints again. If we have this being 0 and 20, we have 0 plus 0 is 0. Can't get too much smaller than that. And the other way around, so x equals 0. So f of 0 gets us 0 plus 20 minus 20, 0. Can't get something even smaller. Try 20. That's going to be 20 plus the square root of 0. Or sorry, 20 plus the square root of 20. That's going to be 25-ish. So 0 is a smaller one. So 1b minimum is going to be at 0. And 20. All right. Maximizing area. Let's scan this. So problem all done.